everyone to the SEG Near Surface Geophysics Technical Section Student Subcommittee webinar series, Critical Skills. And today we're having our wonderful presenters. I'm going to let you two introduce yourselves. We'll start in alphabetical order with Christina, and then we just jump into it.
Hi, I am Christina Keating. I am an associate professor of near surface geophysics at Rutgers University in Newark. And yeah, it's great to be here. And it's also great to see a bunch of familiar names in the attendees list. So hi, everyone. Vivian.
My name is Vivian Ogradima-Dike. I'm a PhD student, concluding under a month. I'm attached to the University of Lille, but it's actually an industrial PhD, and I've spent 3 years with Total Energy here in Po in their research institute. Really happy to be here today to give you what I've learned during the course of my journey. I hope you learn a lot from me. Thanks. Good day, everybody, because I wouldn't say morning, evening, or afternoon, because we are from different parts of the continent right now. So good day, everybody. My name is Vivian again, and today I and Christina is going to talk about how to write a great and effective technical abstract. I'm going to commence at some point, she's going to kick in, but I'll try to make it fast and effective. So during the course of this webinar, I'm going to actually address 3 major points: the types of abstract, because we're talking of a technical abstract, and apparently they are of different types, which I'm going to explain. I'm going to talk about the structure, how to structure your abstract, and the content, and we dive through to the conclusion part. But first, we'd like to understand what an abstract is. From this few summary of what the definition of an abstract is on my slide, it is easy to understand. I think it's just a total representation of what your entire research work is. Your research could have gone for maybe 10 years, 100 years, 2 months, 6 months. It doesn't really matter. An abstract has to be the summary of everything you've done, what you've achieved, and what you think should be done further after your research. I would like to highlight this before I move forward. An abstract is not just something you write because you want to write. For example, some conferences would ask you to submit an abstract. If it's considered, they will ask you for an extended abstract. And if it's accepted also, you can come to give the proper presentation in oral or poster. You don't just draft an abstract with the hope that you get to finish your research on time to attend the conference. No, your abstract is the result. It's just like a summary of the entire research you have conducted and concluded. Worst case scenario, it should be an ongoing research with some results and conclusion you can draft to put in your abstract. Never put a result or construct an abstract with the mindset that you have enough time to conclude what you have put into your abstract, because your results might not actually be what you achieve at the end of the day. So an abstract is a summary of a concluded research or ongoing research with reasonable results and conclusions. That's actually what you see at the beginning of a paper, your manuscript, your thesis, your report. Abstract is one of the first things you see. So it has to be really good. It has to be comprehensive, brief, and concise. What I mean by concise is you need to be to the point. You need to be apt. Abstract should be like 1 sentence statements or a couple of sentences to address what you want to put in your abstract. It is a total advertisement of your research findings. When somebody reads your abstract, you are advertising your findings, your research, and the methods you've used to achieve your conclusions. And it has to be really, really understandable, very easy. Avoid the use of ambiguous words and complex sentences. Make it simple. It's easier that way. Like I said earlier, it's a total representation of your entire paper, and it sets the tone for your research work. Whomever goes through your abstract and doesn't find it captivating and interesting, they're just going to walk away. They won't have the appetite to go through your introduction, let alone head deep into your results section or your interpretation or maybe to even see your conclusion, they will lose interest. So you have to make it very captivating and interesting. There are two types of abstracts. I decide to call them normal abstract and extended abstract. Normally they just say an abstract, but then to be PT in summary and to make it really understandable, I would like to call it normal abstract and extended abstract. For a normal abstract, it's just a couple of 100 words, maybe 150 to maximum of 350 or 400 words, depending on the conference, the journal, or the association to whom or to which you are submitting your abstract to. For an extended abstract, it can be long, maybe a couple of pages, between 2 and 6 pages, also depending where you're submitting your abstract. Very important. These are the attributes of a normal abstract. You just look at it and then you know what should be included in a normal abstract. If a normal abstract is to be just 150 to 350 words, and then you have to compress everything you've done in your entire research for years, for example, my PhD, 3 years, in just 350 words maximum. I mean, whatever you write there should be really brief, like I said earlier. Your introduction has to be brief. Your problem statement has to be to the point. Your methodology, I would like to explain this methodology section. It includes the data sets and the method used with the data to achieve your results. It has to be really brief because all you have is 350 words. You state your data, you state the method you used, and then what results, what were your findings? What were your findings? Try to give 1 or 2 major interpretation, key interpretations from your findings, which could be your observations as well, and then hit the conclusion. An abstract always goes with keyword. These keywords are what researchers could probably search online, maybe try to find a subject online. When they hint it, when they type it, then your paper or your abstract pops out. If it's interesting to them, then they go further to read your work. So you need to be very careful in choosing a very good and specific keyword for your research so that whomever searches those words sees your paper immediately. Of course, feasibility is very important in research. Whatever you do, if you've put in the time to conduct a research, then people need to see what you've done because it adds value to the society. Also know that there are no figures or tables in a normal abstract. It is prohibited. No citations, no references, no acknowledgements, no interpretation section separately. It has to be inculcated into the results within the 350 words. No separate section for discussion and no abbreviations. A normal abstract is a standalone text, just one paragraph of 350 words without different sections like introduction and methods, no. Now, the extended abstract is the normal abstract alone, like I said, with 350 words, with separate sections of introduction, methodology, results and interpretation, then conclusion. Is between 2 to 6 pages, like I said earlier, but with an improved introduction of what, if you have made 1 or 2 sentences, your normal abstract of your introduction, you can elaborate it in your extended abstract. And you need to include citations of studies that you've read or conducted before you selected your problem statement. This will allow the conference chair or the people reading your work to actually know that you've done your review, your proper review, you know what you're talking about. So there must be citations in your introductions to show that you know exactly what you're doing. You've read other people's work and you've decided to address this problem because that is what is actually a gap in the science world that hasn't been addressed yet. The method section must be separate. You have to state the data you've used and the method. Same with the results and conclusion. It's important that you include figures and tables. It's very, very important. Most times you have a lot of thoughts, you know what your research is, but then it's difficult to put it down in writing. If you're a geoscientist, one way we describe what we've discovered is through graphics and line drawings. If you can do that, it's really advised that you can do that, then write 1 or 2 sentences to explain your figures. So it's very important for a clearer overview And for the proof that you've actually done this result, when you're writing it down, we need to see your observations in figures or in tabular format. So you should include minimum of 1 figures or table in your extended abstract. It's very important. You can also add the acknowledgement section, but it's not a must. If you don't have enough space for your extended abstract, you need more space to include more important things, you should discard acknowledgement, except if it's really, really important. Like I said earlier, extended abstract is just like a short paper in summary. Now, to make your extended abstract very concise and portable, when somebody reads it, they understand it. Extended abstract should be in a format that somebody can read your work from abstract to conclusion under 1 hour and understand your entire research work, from what you've done, the method you use, the data, your results, your findings and recommendation. It should be achieved under 1 hour of reading. If a reader is reading your work and under 1 hour they still haven't understood what you've done, then I don't think you've achieved your aim. I'm sorry. So in order to have a concise extended abstract, you need to get rid of too many references. And to do that, you need to choose most important citations relevant to your research and include them in your introduction or your methods or your discussion part to cite them, probably minimum of 5 or 6. You don't go including references of 15 and 20 like you're writing a huge 15 to 10 pages scientific research manuscript to be published. No. Avoid future works or way forward. When you're drafting a manuscript for journal publication, you can include that. If you have a methodology or data set that you use that are really minor or negligible, avoid including them to save space for more important things. Your result and interpretation section, like I said earlier, should be merged. Your observations, your interpretation immediately. No different sections for this. Like I said earlier, if acknowledgement is not important, get rid of it. Now, I know we've been talking about extended abstracts, how to write a critical one. I mean, there is no abstract without a title. You can't send your abstract and then tell them, consider me for presentation without a title. I mean, a title is the first thing somebody sees before going to read your abstract. If there is no title, there cannot be an abstract. So every abstract must first have a title. Although I want to say this, abstract is the first thing that comes, the first test that comes in a research paper. It is always, very always the last section to be written during a research paper drafting. You have to write your introduction, your method, your findings. At the end of your conclusions and recommendations, then you draft out your abstract. I'm going to repeat this again. It's the first thing that comes in a research work, but it is the last to be written when writing a research paper. Your title has to be concise, very simple, straight to the point, without lots of descriptions. It must contain the author's name and their affiliations. Your title must be attractive. Avoid the use of slang. Don't put period. Maximum word of maybe 12 or 13 and minimum of 5. Avoid too much description. Below is an example of a good and bad title. For example, application of gamma ray log. Can you just imagine? Located in Brazil with 5 meter cube area size. That is really descriptive. This is a very good example of a bad title. A good one could be a general one, which is definitely going to captivate a lot of people. The study of hydrocarbon prospectivity in sedimentary basin. Who cares? It's sedimentary basin. It could be in the North Sea, in Nova Scotian Basin in Canada. It could be in Niger Delta, right? Whomever is interested in sedimentary basin will definitely be attracted to this title, then go further to the abstract to be further captivated to attend the oral or poster presentation. You see that? Your research is being disseminated. Now, abstract and introductions are similar. Very, very similar. They both have their motivation, their problem statement, their objective, the methodology, the finding and conclusion. Only that your introduction is a more robust and enhanced section of your abstract. What you don't get to include in your abstract, you include it in your introduction. Like I said earlier, it appears in the beginning of a paper, but it is the last to be written. Your introduction, like I said earlier, I think I've literally talked about this part. And your methodology, when you're writing it, you need to mention the available data sets, the data set that were made available for you to conduct your research. You need to hint on the data, on the method you use. These are the examples of data sets and method. Don't get them mixed up. You can conduct your attribute analysis, well correlation, and sequence stratigraphy analysis using these data sets. So using the well log and seismic, you use the method of attribute analysis and well correlation and sequence stratigraphy to achieve your results. So don't mix them up. Try to make sure you highlight the available data and the method you use step by step to achieve your results. It has to be properly explained, and you must probably, most often the case, cite whose method you are using. For example, if it's sequence stratigraphy, are you using the Katanuyenu method? Which year? If it's seismic attribute analysis, are you using the Chopra method? Which year, which paper? Like, cite it and then include them in your references. It is very, very important. Your result and interpretation, like I said, goes hand in hand. But first, this section is very, very tricky. You need to make sure you make an observation first before you interpret. You don't just dive into interpretation. If you've made an observation, don't assume that your reader or your audience already knows what you did. Don't assume these guys did not conduct this research with you. Make the observation and make sure you have a proof in your image or your figure where this observation is, and then you interpret what you think it is. You must first make an observation before you interpret. And after that, you discuss. Compare with other researchers' work. What did they say when they conducted this research in another area or maybe in your area? Does your result conform with what theirs is? Or is it against? If it's against, why do you think it's so? If it is, that means it's actually confirming what they say. You need to try to make comparison of your work, of your results with what other authors have done. This really shows that you've done something good. You don't just state your observation, result, and discussion without comparison with other research. It doesn't work that way. This is still an extended abstract, but it seems like I'm going too far into research paper. The truth is, for you to be able to write a very brief, concise, and well-represented extended abstract or abstract, you must already know how to write a full research paper. You must have a foundation, a fundamental knowledge of it. Without it, it might be a bit difficult for you to be able to put the entire work you've done into a little piece. So that's why I'm trying to go a bit deeper, so you have a proper and general overview of how this can be made a very good abstract if you decide to shorten your work into pages or a few hundreds of words. Your figure should be a standalone caption. It must be very clear. When you put a figure, there must be a caption explaining what it is in your extended abstract. You don't just put a figure and say, this is figure 1, and that's it. Figure 1 is Submarine Canyon. Submarine Canyon doing what? What do we see in your images, right? You need to put a brief explanation in your caption of what the images are, so that the people reading your work will know that you actually know what you're doing. This is an example of a figure. It is clear. You can read it. It is readable. Although this caption seems really long, this figure is meant for the purpose of an extended abstract. It's like the combination of an entire research work for 1 year in a single figure, explaining the effect of fault, shale ridge, on the evolution of Submarine Canyon, the different evolution of the canyon, the different canyon systems, the fascies contained in the canyon, the geomorphic features like the MTDs. You see, with a single figure, you can interpret your entire research work. This is what you should be doing in an extended abstract. 1 figure or 2, but it should be really concise and understandable. In your discussion part, like I said earlier, discuss your interpretation, compare with other authors. If the problem is solved or not, you need to state it and say what your limitations are. What are your limitations? Due to that limitations, are you really recommending other study to be done or not? If you've actually achieved your aim, well then good, state it. And you also have to highlight the significance of what your achieved result is. Okay, now we are in the conclusion section. So like I said earlier, an abstract is a single paragraph. You can rephrase the problem and objective. That is mostly in your conclusion part. This conclusion is just like an abstract. Most of the time, it can be like a single paragraph, but most authors like to make it in ones or twos with bullet points. But for the purpose of an extended abstract, you have limited pages. So you just simply make it a single paragraph explaining, just reiterate your problem statement and your aim, right? Reiterate it again, then state what your findings are using the method and the data sets you have, and then the conclusion. But don't go repeating exactly what you've stated in your introduction and your interpretation and discussion section. No, reiterate it, but paraphrase, make it something new. Don't be repetitive. It's not very good. It's not a good advice or good thing to do in an extended abstract. It might get your work rejected. So according to Andrade, he made some point on how an abstract should look like. Should be condensed and concentrated version of a research manuscript. We can all read it. It must be detailed as possible and with the word count that has been specified for this abstract. You must also make sure that the research outcome and conclusion is included. It is very important, whether it's a normal abstract or the extended abstract. For me to conclude general, let me repeat this. An abstract, a normal abstract is between 150 to 350 words. And it must include everything you've done, your motivation. If there is no motivation, a brief introduction of your work, your problem statement, your data set, your method, your results, and then your findings is very important. In your extended abstract, you must have this, but they should come in different sections. Abstract is different. Introduction has a separate section, method, separate section, results, and discussion. Then your conclusion, and then you must include your references. You must include the references of the citations you made in your test while writing your extended abstract. If there's an acknowledgement, you must include the fund, the resources, your personal assistance, all the entities involved in the success of your research must be highlighted in the acknowledgement section. Thank you very much.
Thank you, Vivian.
Yeah.
Okay, awesome. So thank you, Vivian, for that very comprehensive overview of the abstract and the extended abstract. So let's just, quickly take a closer look at the summary section of an SEG or an image conference abstract, right? As Vivian mentioned, the abstract needs to contain certain things, right? It needs to contain the problem statement. It needs to contain the objective of what you're trying to do with your research, information about the methods. It needs to contain the major findings, and it needs to contain the conclusions or possibly the future directions of your research, right? And so this abstract, really what it looks like is just kind of a mini paper. So the abstract that we're doing for the summary section, or like a normal abstract, this is a really, really condensed version of the paper that's highlighting the important pieces of your research, right? As Vivian mentioned, most people are just going to read your abstract. They're not necessarily going to read your whole paper unless the abstract is really compelling. So if you can create a compelling abstract, if you can create a compelling summary for your extended abstract, you're going to get people more interested in your research, and you're going to get more people reading your paper, which also leads to more citations. So that's all great. So writing an effective summary section, writing an effective abstract is really important. So what is the problem statement? All right, so the problem statement, it really gives a context for the research. You need to explain what's already known about the subject, and related to your research, and what is missing. What is the thing that needs to be figured out about this area of research that you're working on? In an abstract, this problem statement should be about 1 to 2 sentences long. We then have the objective statement. So the objective statement explains what you intend to do with the study or what your paper seeks to present. The objective statement in this abstract should be about 1 sentence long. You then kind of explain what you did to address this problem. How did you meet your objectives? You provide detail on what was done to address the problem, so you can explain briefly what was your experimental design, what were your analytical techniques used, how many samples did you use, and what were the parameters of the samples that were important. All of this in an abstract needs to be done in 1 to 3 sentences long. So this is like a really kind of short description that's an overview of your whole methods. Next, you state, what are your major findings? So what were the take-home messages of the results? These are not the details of the results. You're going to leave that to the actual paper, the extended abstract itself. But you want to say, what were the most important things that you learned about your research? And you need to be able to say those most important things in 1 to 2 sentences. And then finally, you state what the conclusions and the future directions of the research. So you conclude and you provide some context or information for the importance of the research. So you can talk about how will these findings be used and why is this research important or why is it impactful? And these conclusions and future directions, they're approximately only 1 sentence long. So all of these different things, there's a lot of information included in the abstract, but you have to be very, very concise about how you conclude it or how you write these things, because there's not very many sentences within your abstract that you have space to be providing all this information. So you have to be precise with your language. And just echoing what Vivian said earlier, you have to be precise with your language. You don't want to use really complex sentences and complex words, because you have to be really clear about everything that you're saying. So now I want to go through a couple of activities. I wrote an abstract just before coming to present to you guys, and I wrote an abstract that has no science in it. So everybody should be able to hopefully understand this abstract. The only point of this abstract is to explain how an abstract is written, the composition of an abstract. It doesn't actually give you any information. So I'm going to read this abstract. Okay, the title of my paper is, in this paper, we write a summary without any of the actual science. So in area of science A, it is critical to understand how B impacts C. While previous research has attempted to understand the impact of B using XYZ analytical approaches, no one has been successful at doing so. In our research, we aim to address this gap in the scientific understanding of B and C by applying QRS novel methods. Our study used N measurements across M different parameters to examine the properties of B and C. Our results demonstrated that these properties are fundamental to improving our scientific knowledge of B and C. Ultimately, these findings will transform the way in which B and C are applied in A. So obviously that kind of is nonsensical. It doesn't really make any sense. It doesn't have the scientific content that you would want your abstracts to have, but it does have the structure of the abstract that we're looking for. So I'm going to go through that again, sentence by sentence, and point out what the structure of the abstract looks like. So here we have the problem statement. In the area of science A, it is critical to understand how B impacts C. While previous research has attempted to understand the impact of B using XYZ analytical approaches, no one has been successful at doing so, right? So we have stated what the big context for our research is, and we have stated here what is missing from the body of scientific knowledge. We then go to the next thing. In our research, we aim to address this gap in the scientific understanding of B and C by applying QRS novel methods. This is the objective of our research. Our objective is to address the gap in the scientific understanding of B and C, right? We are stating what the objective is here in 1 sentence. We then state, our study uses n measurements across m different parameters to examine the properties of B and C. So in this next sentence, in one sentence, we've sort of summarized our methodology of how we're going to solve this problem. You could say that second part of that last sentence by applying QRS novel method, that's also a little bit part of the methodology. So it can be a little bit ambiguous where these sentences fall into. But the key is that so far we have our context, we have our general problem statement, we have our objective, and then we have our methodologies. Next, we say our major findings. Our results demonstrated that these properties are fundamental to improving our scientific knowledge of B and C. Obviously, these are very broad and not very specific and don't actually give you information, but the idea is there, right? Our results demonstrated this thing. We are showing what the major finding of all of our results is, not specific details and not like small things about our research, but what is the big overall major finding. And then finally, we say, ultimately, these findings will transform the way in which B and C are applied in A. This goes back to giving context again. What is the importance of our research? Why is our research compelling? Why is it going to transform the way that people do science? How is it going to impact the field? So this last statement, it gives a conclusion and it tells us our future directions. This is where the research is going. This is why it's important. All right. Okay. So now that you kind of have this like theoretical understanding of how to write a research abstract or summary that doesn't actually have any information in it, let's go to like a real example. All right. So this is the summary of an extended abstract taken from the Image 2022 conference. The title of the abstract is Machine Learning-Based Anisotropy Characterization of Wolkamp Shales in the Midland Basin. It is written by Jae-Wook Lee and David Lemley from the University of Texas at Dallas. Okay, so this abstract clearly has actual information in it. It is from a real scientific study. And so we're going to basically use this abstract and go through the same exercise we just went through with that pretend abstract. So the summary of this is understanding the anisotropy parameters of organic rich shale formations is important to interpret seismic amplitude variation with offset AVO data and estimate shale-specific reservoir properties more accurately. In general, we can quantify the elastic stiffness coefficients and Thompson anisotropy parameters from vertical seismic profile and advanced dipole-sonic logs. However, since many log data are not acquired with these tools, we seek to develop an alternative method to estimate the anisotropy parameters from conventional well logs. In this study, we propose to predict these parameters from 3 shale rock property logs based on the 3-phase statistical shale rock physics model, such as porosity, clay volume fraction, and kerogen volume fraction. First, we estimate the elastic stiffness coefficients from 3 rock properties using Shapley value regression analysis. With the Shapley values of 3 inputs, we quantify the effect of 3 rock properties on shale seismic anisotropy. Then we test 4 types of machine learning techniques to improve the accuracy of the estimation functions. Moreover, we generate the Thompson anisotropy parameter logs from the estimated stiffness coefficients. With this anisotropy information, this approach may help to invert more accurate reservoir property models from seismic AVO data and provide better shale reservoir characterization for hydrocarbon and kerogen. I want to point out one thing before we move forward. This abstract contains acronyms, right? Vivian stated earlier that the abstracts shouldn't contain acronyms, and this kind of like violates that rule. That rule is like pretty standard for most journals. I don't think it's specific to the summary of an extended abstract, but that is something you should keep in mind. Okay. So we're going to go through that same activity. Now, I think, the knowledge to understand exactly what's going on in this abstract, it requires you kind of to know a lot about like seismic and to understand what these methods are and to understand what the rock physics are. To know how to kind of analyze the specific abstract for the pieces of the components of an abstract doesn't actually require you to understand the science of this abstract. So for instance, we can look at these first few sentences and say, this is the problem statement. Understanding the anisotropy parameters of these organic rich shale formation is important to interpret seismic amplitude variation with offset data, right? We can also say here that they state how this is done, and then they state where the missing knowledge is. Many log data are not acquired with these tools. That is the missing data. That kind of sets up the problem. The problem is then, or sorry, not the problem, the objective that sets up the objective. The objective is we seek to develop an alternative method to estimate the anisotropy parameters from conventional well logs. In this study, we propose to predict these parameters from these rock property logs based on this model. And then there's the methods. We use the shapely value regression analysis. We use it with 3 different inputs. We test the machine learning techniques to improve the accuracy of the estimation function. And then finally, the use of moreover here, I find a little bit confusing, but overall, they find that they can generate the Thompson anisotropy parameter logs from the estimated stiffness coefficients, and they give a conclusion and a future directions. With this anisotropy information, this approach may help to invert more accurate reservoir property models from seismic AVO data. So, so you can go through any abstract and you can identify these components. Not every abstract has all of these components within it. You'll find as you go through different abstracts, one piece might be missing, a different piece might be missing. But I would argue that the most effective abstracts have all of these different components in them. In my view, there are kind of 3 ways in which we learn how to write effectively. The first way that we learn how to write effectively is knowing what components, like knowing and understanding what goes into writing, right? So attending presentations like these and kind of learning about the components of an abstract, the components of an extended paper. The second way is writing, right? Going around and writing and getting feedback on your writing. But a third way that I think we don't always consider as being important in writing is reading, right? Going through previous abstracts, reading them critically to understand what components are there, what pieces of information are there in the abstract, and dissecting those pieces of information. Hopefully, can everybody see this? I have sent a file to everyone via the chat link. So you should be able to open that file. This is an actual abstract from the image conference in 2022. And I would like you all to just take sort of 5 minutes silently to kind of identify from this abstract what these different components are. And I'm going to go back to the beginning of the presentation so you can kind of see, here are the different components that you want to identify. So just take a minute to see if you can find the problem, the objective, the method, the major findings, and the conclusion and future directions, keeping in mind that not every abstract has all of these different components. So if you cannot find one of them, it might be because it's not there. So take just a few minutes now to do that. And you're not reading through the whole paper, just the summary of the section of the paper. All right. Okay, I'm going to bring everyone back to the presentation now. So now that everyone's kind of, everyone has had a chance to have a look at that. Does someone want to pop into the chat the sentences that cover the problem? What is the problem statement here? So if you can sort of cut in place the couple of sentences that are the problem statement, I guess, well, not everyone can cut it. Hugo says ground penetrating radar is the tool of choice for fast near surface structure and anomaly imaging. A clean high resolution GPR image is crucial to reduce uncertainties in near surface interpretation. So that's exactly it, right? There is the problem statement, right? The first two sentences show the problem statement. What is then the objective? Can someone pop into the chat what the objective would be? So Kurt says, we develop a general purpose end-to-end machine learning approach to achieve high resolution GPR images in real time. And that's exactly it, right? That is the aim and goal of this. We develop a general purpose end-to-end machine learning approach to achieve high resolution GPR images in real time. What about methods? You know, in this summary, which they don't always say in an abstract, right? It says our method. So that gives a clear indication of what the methods are, right? Chris says that everything until the last sentence, right? Our method is based on a supervised attention-based neural network where we train the neural network using a multi-scale supervision functionality and improve its feature learning capability using an attention-based block at multiple spatial scales. We also develop, so that's also part of the methods, we also develop a procedure to generate highly realistic synthetic GPR images for this neural network to accurately produce high resolution images for field data applications in different scenarios. Okay, so then where is the major findings? There's only one sentence left. So it could either be the major findings or the conclusions and feature directions. But that major findings is really the synthetic and field data examples show the good generality and fidelity of our method. In this particular abstract, they don't state what a conclusions or future directions are, and that's okay, right? Not every abstract has every single one of these elements, but most effective abstracts do have all of these elements. So with that, I guess I will turn it over back to Lori to moderate questions.
Okay, great. Thank you. Excellent presentations from both of you. Wonderful.
I think Anas asked if he could have the slides.
Yeah, actually, you're going to have better than that. The entire recording will be placed in the SCG YouTube channel. And I can send a link to that to everyone who's registered and attended. So that'd be great.
In the extended abstract, does each section have a word limit? And is it also a single paragraph? Vivian, I'll turn that to you to answer.
Yeah, okay. I think extended abstract word limits are probably 1,000 words in general for the entire page, but I think it's conference dependent and association dependent. Some association would tell you maximum of 6 pages, some will say 3, some will say 4 without the references like the SCG. So I think the maximum word limit is most restricted to the abstract, the normal abstract section, but for the introduction and the rest, it is up to you to maximize your page, so you'll be able to add as much as you can. There are no limits for introduction or methods or discussion or whatever. You only have pages limits. That's all. Yeah, I think it's up to you to, figure it out and make sure you include everything you need to include and make it concise and more comprehensive, easily readable, and highly captivating, so your audience would read the rest of your research.
Thank you. Our next question asks, if you're writing an abstract for research that has not finished, like, for example, a grant for grant purposes, how do you deal with the conclusions and results part of your abstract?
Yeah, so, you kind of change, you adapt how your abstract looks for the purposes of your writing. And I would say for a grant, you typically have specific things that you need to include in either your abstract or your summary. So those might differ from what you would include in an abstract for a paper or an abstract for an extended abstract. For example, the National Science Foundation requires you to have things like broader impacts, like a broader impact statement and an intellectual merit statement. So you have to adapt your approach based on what you're writing. But in a grant, you're typically, again, not going to have results, but you do have some ideas of how your research is going to impact the field, right? So your conclusions and your results in that abstract are going to be like, this research is going to transform the way that we do science. It is going to be incredibly impactful, and it is going to, I don't know, it is going to change the way in which we manage coastlands across New Jersey. I happen to know what Chris's research is about, so that's a relevant topic. But you transform what you write for your conclusions depending on what purpose your abstract is serving.
Awesome. Okay, let me just chip in a little to that. Thanks a lot, Christina. That was really, I think you said it all. But then if it's a grant, I guess it's just a proposal. It's not a research yet. You just began. So like Christina said, you adapt your abstract depending on what you're doing at the time. If it's for research grant, and it's definitely proposal, I think you don't need to put the results. Like she said, your anticipated results, what problem it stands to solve, the significance of your expected outcome from the research. I guess that is all. Okay, if it's an abstract, put, just like she said, methods you intend to use, whatever, but don't put results. Where you intend to put your results is where you should put your anticipated results, not your results. And your conclusion, what it stands to solve, and importance. I think that's just it. But that was a good question. Nice one.
We have another question. Please, will a good abstract not have a conclusion?
I think a good abstract should have a conclusion. I think this question and the next question kind of go together, right? Braulio also asks, I didn't understand why we didn't have a conclusion in the summary section of the last example, right? And I mentioned this a little, but not every abstract is written perfectly to this formula. I think effective abstracts have all these components in it. So when you write an abstract, you might want to include a conclusion. But this is part of why we read other papers, why we read other people's writing, and why we read it critically, both in terms of what components are and in terms of the scientific content. So we can read abstracts for their structure and criticize that structure in the same way that we can read a paper and criticize the scientific content and methodology of the paper. And so I think, a good abstract would have the conclusions in it. And that abstract that we read, I thought it wasn't a bad abstract, but it might have been made stronger by having a conclusion in it.
Can we argue that the new procedure is also a finding?
That's new methodology. It's something that you created. So of course it is. New procedures is new methodology. The methodology we use today was created by somebody, and it was his or her finding. So it's a result of a research. That it's a methodology or a procedure doesn't mean it's not a result. It's actually a result. So of course it is. Absolutely. What do you think, Christina?
I agree. I mean, I think that, a methodology is like a methodology paper are really important contributions to the science, right?
Yeah.
Your methodology, your findings of that methodology are often that the approach works, that it's an improvement on previous approaches, right? And so that's part of, I think, that last abstract that we looked at, the GPR abstract as well, right? They said that synthetic and using the approach on synthetic and field data demonstrated that it was effective. Yeah. Right. So that is part of your findings within presenting the approach and presenting the methodology. Yeah, and just to add, I really, encourage everyone when they're preparing abstracts for a paper, or when they're preparing papers or extended abstracts for anything, go through and make sure you read papers and abstracts from the journal that you're going to be submitting to, or the extended abstract conference that you're submitting to, because that really helps in your own development of your writing. So, all right. Well, thank you so much.
Yep.
Have a great day, everyone. Bye.
Thank you.
You too. Bye.
Bye-bye.